Okay. Topic is Heisenberg uncertainty principle.
Spelling, sir.
Heisenbergs. So Heisenberg uncertainty principle. According to this, the position and the position and velocity are momentum. The position and velocity or momentum of a particle cannot be calculated cannot be calculated simultaneously with accuracy. So, okay, so that means accurately the position and momentum of a particle, okay, microscopic particle like electron, proton, neutron, no, cannot be calculated. Okay, I will tell you how it will become uncertain. And according to this theory, he had derived one relation also. Okay, that derivation we don't have. Just I will give you the formula. Just remember that. Okay, that is delta x into delta v, which is greater than or equal to h by 4 pi m. Okay,
Sir, delta x is equal to, sir.
I will tell you now what is. Wait, no, delta x equal to uncertainty in position.
సార్ ఇందాకే ఫోన్ చేశారు
What happened?
మొత్తం గ్రూప్ కాల్ చేస్తారు ఒకసారి
Sir, h by 4 pi m, sir.
Yes, 4 pi m. Delta v equal to uncertainty in velocity. From this, నాకు కొద్ది సౌండ్ తగ్గించవా? సరే నేను సౌండ్ తగ్గిస్తుంది డాడీకి ఒకసారి 1 second స్టూడెంట్స్. So from this one what we can write, delta x into m delta v, which is greater than or equal to h by 4 pi. Here mass into delta v means what? Uncertainty in the position, that is delta x into delta p, which is greater than or equal to h by 4 pi, where delta p is uncertainty in the momentum. And here m represents mass of the particle. Mass of particle, and h represents Planck's constant. Planck's constant. Okay. This is what we can say about the Heisenberg uncertainty principle. So why we can't calculate? Okay, why we can't calculate both with accuracy? The reason is, let me assume. Let me see this. For example, all of you listen clearly. For example, a particle, electron, proton, electron. Let me take. Okay, so electron is moving in this direction. Let me take like this. Okay, and this is the path. Okay, so from here, so it will revolve in circular path, right? So from here, electron is revolving like this. Now, so if electron will revolve with certain speed, okay, and if you want to find out its position, okay, if you want to find out its position, so generally we will use some instrument like microscope or something. We will use, no, yes or no? Some microscope or something we will use. Okay, we will use some microscope or something else we will use to identify the, okay, to identify the position of electron. So when we want to see the microscopic, no, with microscope, if you want to observe, no, so we need to use some kind of light we need to use to see, light, UV light or visible light or any type of light we need to use. So when we are using such kind of light, no, so light means what? One form of energy, no. So this electron will gain that energy, and instead of coming like this, it will move in this direction.
It will go out of the path, sir.
Understood what I'm trying to say? That means if we are trying to find out its position, no, so velocity become uncertain. Or if we are trying to find out its position, velocity become uncertain. Or if you are trying to find out its velocity, position will become uncertainty. Okay. So in this one,
Sir,
you people
our velocity position will be uncertain.
come again.
How if we see velocity, our position will be uncertain?
That only I said no just now. So if electron is revolving in this manner, okay, and if you want, for example, here initial electron is there. Let me take after 10 seconds. You are finding out, you are calculating this electron will be like this with it some principles. Okay, you are trying to assume that electron will remain here. So to check, we are electron, so we cannot be observed with naked eye. So something we will use some ultrascopic microscope or some extraordinary microscope we need to use. And to use microscope, if you are using also to observe that whether the electron is present here or not, so we need to use some light, no, some different kind of light we need to use other than normal UV light, normal light. So when this light also one type of energy, no, yes or no? So this energy is taken by this electron and it will move in another direction. Okay, actually the electron initially supposed to come in this way,
Yes,
but
sir.
as it is, and if it is coming in this way, and we are trying to calculate that position of the electron should be here, and at this position we will think velocity is fixed. To find out that whether it is reaching the same position or not, we will use some microscope to check. So when we are using, we will use some type of light. Okay, some light required. That light energy also gained by the electron, so that it velocity will changes, so that its position will also be changes. That only
Sir,
I am saying that if I'm trying
sir,
to find out position, velocity become uncertain.
that means it will change its orbit.
Ah, yes, it will change its orbit.
If we go
Okay,
out of the path, sir,
Earlier previous
out
slide.
of the orbit means what? So that is the reason only. So according to this theory, okay, according to this theory, Bohr's theory is ruled out actually. Bohr's theory, what he said, there are electrons for there are circular paths are there, no, for revolving of electron. Isn't it or not?
Yes, sir, where energy remains
But
constant.
whereas according to this, he is saying that there is no paths for any electron, because electron position and momentum you can't define, it is revolving in the same direction only. Okay, so based on this theory only, we are going to discuss Schrodinger wave equation, etc., etc. We are going to discuss in higher classes. We will discuss.
Sir,
Understood
that
what this theory?
means we do not check whether the electron is revolving in that direction or that position only, it will remain the
Yes,
same, no, sir.
yes. What? Come again?
Sir, if we does not check with the microscope that the how electron is moving with what speed, it will be same only, no, sir.
But actually, you should identify, no, whether it is moving in same speed or not. You want to find out, no?
Yes, sir. We don't know. Uh, we don't know what is its speed and position. When we are checking, it is changing it.
Actually, we know position we are thinking. So for example, let me assume, okay, in future classes you will study in physics. For example, you are at a five-stair building now. Let me take. Okay, you are at a five-stair building. Stair means five-floor building you are having. Okay, and from here you are trying to throw a ball. Okay, which ball? Like let me take a soccer ball you are throwing. Okay, with some when you are throwing, no, so obviously it will reach to ground, and in the ground let me take it is taking uh, 10 seconds, let me assume like this. So when 10 seconds it is reaching to ground, so at fifth second can you calculate, no, where the ball and what is the speed of the ball?
No, sir.
We can calculate or not? Uh, in the
Yes,
same
sir.
way, from the same position, if you try to instead of ball, you try to throw a small dust particle like chalk particle. Okay. Let me take to reach this also. Let me take it is reaching 15 seconds. Okay. At seventh second, can you predict where the particle is?
No, sir.
Was
Why?
so because
Sir,
that
because
rocket.
we can't see it and
Because
it
of the
is
wind,
in the
no? So
air.
it can move in any direction or not. That means what? For
Yes.
the case of particles, like small particles, we can't find out position and velocity simultaneously. No? Whereas microscopic particle, you can calculate position and velocity. You are able to calculate, isn't it or not?
Yes, sir.
That only he said.
So,
Understood?
sir, I have a doubt.
Ask me.
So delta x into delta v is greater than or equal to h by 4 pi m. Then how can we get from this delta x next step? How can we get, sir?
Here just m I had kept here, Nana. Rearranged. Greater than or equal to means what? Equal to symbol also there, no? We can change in any direction or not.
Sir,
So
for
m
greater
is in denominator of right side. When
than
it is coming to left side, then what will happen? It will become product only, no?
sir, we can change for greater than or equal to also, sir.
Yes, yes. You can change for greater than or equal. That we are saying you are going to study in maths. Okay, that is under topic of inequalities.
Okay, sir. We
Inequalities.
did not get yet, sir.
Okay, you will study in higher classes.
Sir, I did not understand what how you did that equation, sir.
I told you, know, that equation where he had derived, but the derivation part we don't need. That's the reason I'm not giving. Just giving like a
Sir, you
formula.
directly wrote it.
Yes, yes.
Okay, sir.
So delta x delta p means can we write a common, sir? Delta
No,
x into p.
no, no. Delta x is different. Delta p is different.
Okay.
No.
Sir, 1 minute, sir. 1 minute, sir.
Mummy, కొద్ది
Sir,
కిందకి రా.
this much only, sir, this topic.
Yes, yes. This theory that only.
Sir, then what we will write for questions exam?
Arey, yaar, first you complete, no? Then I will give you, question which type of questions they are coming.
Okay, sir.
Bas.
Sir, this Sunday will there be chemistry test, sir?
No, we will see that, Nana. You will get information. Please wait.
Okay, sir.
Okay.
Sir, not completed, sir.
Make it fast. Once you complete, tell me.
Okay, sir.
Done, sir.
No, sir.
You can move, sir. Sir.
Done, sir.
Mm. See, this is what about the topic, right? Mm. Next concept is quantum numbers. Okay, quantum numbers. So what are the quantum numbers? Okay, generally these quantum numbers are uh, okay prescribed to get more information about the electron in an atom. Okay, these quantum numbers are mainly used to prescribe the what we can say position, somewhat more information about the electrons. We are having, let me write, quantum numbers are described, sorry, quantum numbers describes the quantum numbers gives information electron of a atom. Okay, generally we are having four quantum numbers, that is, first one, what is the quantum number? We are having principal quantum number,
Sir, I have a doubt.
one second Anna. Tell me.
Sir, these quantum numbers are used to describe only electrons or protons and neutrons also.
Electrons position only gives more electron proton information about the atom.
Oh, protons also, sir.
Electron proton somewhat more information about the atom.
Okay, sir.
Okay, uh, gives information about the atom, this is correct. Okay, principal quantum number. Next
Azimuthal quantum number.
mm,
Magnetic quantum.
one second, azimuthal quantum number. Third magnetic quantum number.
Magnetic quantum number.
The spelling, sir.
And
Spelling
last.
is it? The spelling, sir.
What happened?
Sir, AZIMUTAL, sir.
Yes, yes.
Sir,
Last
I
one.
MUTH na sir.
Huh?
MUTAL or MUTH, sir?
TL only.
Okay, sir.
Spin quantum number. Mm,
That's the
Spin
information
quantum
like
number. Next.
it's like its location, right?
Yes, it will give what is its position, what is the energy. Okay, that all we are going to get.
Okay, sir.
Sir, in azimuthal quantum number AZIMUTHAL, no sir.
Array, yaar, what is there in spelling here? I don't know. THAL only. Okay. So now, what we are going to get information about the principal quantum number.
Yes, sir.
principal quantum number which we represent with n. Okay. This quantum number was proposed by this is proposed by Niels Bohr. Okay. And
Sir, it is also by both,
designated
sir.
Bohr BOHR NEILS
Okay, sir.
Niels
Okay, sir.
Bohr designated as
Sir, Bohr's theory, Bohr only, no, sir?
yes. Okay. N. So it was represented given by n, and what this information gives, and n values are general.
Sir, can you go to the previous slide?
N values are 1 second. Starts from 1, 2, 3, 4, 5, so on. It will be there.
Done, sir.
Mm. 1, 2, 3, 4, 5. Next, n value gives information about number of cells, size is nothing but radius, and energy of the cell. Do you remember in Bohr's theory only we have discussed no radius?
Yes, sir.
Yes, sir. Yes, sir.
Same way.
Sir, once could you move to the previous slide?
Sir, so the values are from 1 till where, sir? Like max. Is there any maximum number?
No, n infinite.
Okay, sir.
Sir, done, sir.
Okay, this will give us number of cells and size and radius. This only information about the n. Next one, azimuthal quantum number.
Sir, I have a doubt.
Tell me.
Sir, if we write a principal quantum number, how can we know whether it's describing the number of shells, radius, or energy?
In
How
an atom,
can
by writing electron configuration, we can predict know how many
yes,
cells are
sir.
there. And from there, by knowing n only, he had given no energy of cell equal to minus 13.6 by n square formula, and radius equal to 0.529 into n square by z.
Oh, okay, sir.
From there
Yes,
only.
sir.
Done.
Wonderful.
Yes.
So azimuthal quantum number proposed by
Azimuth.
my Sommerfeld and designated with L. Okay, and this L values depends on, okay, L value depends on n. Okay, uh, L values depends on n. Okay, and the value starts from, and the value starts from starts from 0, 1, 2, 3 up to n minus 1. So overall value, how many values, Nana? 0 to n minus 1 means
Infinity.
Infinite, sir.
n values, no?
Yes, sir, infinite.
Right,
Yes, sir.
n, no? N if I'm taking for 5, I'm taking.
Yes, sir, yes, sir, yes, sir, yes, sir, yes, sir.
Total
4,
values
sir.
how many? N only, no?
4.
Doreku.
Yes, sir, and
Okay, na? That means what we can say, for any n value, there are same number of L values exist. For example, let me write. For example, n equal to 3 if I'm taking. Then what are the L values? Tell me.
2, sir.
2, 1, 0.
210.
0, 1, 2. Total values how many? 3 only, no?
Yes.
Yes or no?
Sir,
That only I
Yes.
said. Okay.
sir,
Uh,
sir, if n is equal to 1, the
then it will have only
L
one
value
value, that is 0.
zero.
That I'm
That's why
writing it.
zero
Go to the
is
previous slide.
included in this, sir.
Uh, 1 second. If L equal to 4, then L values are how many? 0,
4,
1,
2.
1, 2,
2,
3.
3. If n equal to 2 means
0, 1.
0.
n equal to 1 means
0.
1, 0.
0.
0. Okay,
0.
L equal to 0. Okay. What you are asking, Shashank?
Sir, I am asking that if n is equal to 1, we have to have one essential quantum number so that we included 0 in that.
Yes, yes.
Sir, can you go to the previous slide?
1 second, 1 second. Let me finish this. Then I will after that I will go. Okay. Generally, what he is saying that L equal to 0, okay, L equal to 0 represents S orbital. Okay, and L equal to 1 represents, what it represent? P orbital. You need to remember this. Okay, na?
Yes.
Orbital or a subcell, we can say. If L equal to 2 means
So D.
D orbital.
D orbit.
Sir,
Next
what are
step.
subgroups?
If L equal to 3 means
F orbital.
F or
orbital is also known as subcells.
Sir, could you show subshells in a diagram, sir? Can you demonstrate by diagram?
So next slide, sir. Once, only once. Next slide.
Done?
Yes.
Next slide, sir. Next slide.
Yes, sir.
Previous or next?
Next, sir. Next.
Okay.
Sir, could you demonstrate subshells by a diagram, sir?
Diagram is how to express non orbitals, how we can write subcells.
Sir, I have a doubt,
Sir,
sir.
subshells
Tell
means
me.
are they
Sir, what if n is equals to 0, sir?
Which one, Anna?
Sir, what if n is equals to 0, sir?
N equal to 0.
Yes, sir.
N or L?
N,
sir.
sir.
N equal to 0 will not exist only, no, N value.
Okay, sir.
Okay. So orbital is also called as subcell. Wait, I will tell you who is asking. No, let me see once. I will tell you. Okay. So generally,
Sir,
L gives information about.
Sir,
Hmm?
sir, if n is equal to 1, it is s orbital only, no, sir?
That all I am writing, Nana. Please give me time now. If L gives information about number of subcells of a main shell. For example, this is first shell if I'm taking. Okay, with respect to this, and it is having only one cell like this. Okay, na? And second cell if I'm taking, so it will have what? 2s and 2p. Likewise, we can have. Understood, Nana, what I'm trying to say?
sir, could you repeat?
Sir, can you on it?
One second, one second. Mm, okay. Diagrammatically, we can't represent, Nana. Okay. That means what we can say, for example, let me say, for your easiness, I will write, but this is only for your easiness only. Let me take, this is shell. Okay, na? First shell. So in that one, we are having only one subcell. Subcell I am indicating with box like this. That is, this only known as 1s orbital. If I'm taking second cell, if I'm taking, so it will have two subcells, no? That is,
2s and 2p.
there are two subcells, no? That is, one is known as 2s and one is 2p. And if I'm taking third cell if I'm taking, it will have three subcells, no? That is 1, 2,
3s.
3SP.
like that. Okay, na? You can write like this.
Sir, it is 3s, 3p,
Yeah.
3d.
3D.
Okay, na? So let me take that as number of subcells in first
Sir,
cell. What we can write?
electrons can exist, sir.
Which one?
Sir, electrons can only remain in orbitals only, sir.
Yes, yes.
Other than that, it can't be anywhere, sir.
Nothing.
Sir, can you show the
Number
Sir,
of
can you
slide?
go to the previous slide?
number of subcells in second cell is
Sir, and first, sir, what is that? 1s.
1s orbital, no?
Yes, sir. Yes.
Uh, Number of subcells in third cell is
3s, 3p, 3d.
3p,
Sir,
3p.
yes, sir. Third cell, 3 subcells.
Fourth cell,
Sir, 4s,
4,
4p, 4d.
4P, 4D, 4F.
4s, 4p,
that one.
4d,
Okay, okay, okay,
4f.
okay, quite. Okay. Fifth cell, it will have like this 5f, 5g, like that it will be there. But g
Yes.
orbitals also there, okay, which we are not using.
Sir, can you show the previous slide?
Sir, only these exist, sir.
Which one, Anna?
Sir, 2f, like that, other combinations don't exist, sir.
G also there, and after that H also there. But only thing is C. But whatever the elements we have right now, yes or no? Whatever the elements are there, no, that elements simply what are the elements are there, no, that element simply we can find it out.
Okay, sir.
Okay.
Sir, 2F like that they don't exist, sir. 2D.
2D it will not exist.
Okay, sir.
Okay, na? That means, for example, say, as I said, no, in box method, first cell, second cell, like that. Okay, this will have, okay, this will have, for example, likewise only we can represent like this. I have taken in box. Okay, if you are, for example, if you're saying in Google also, we can find it in different way, like 2S, 2P, like that, it will be there.
Sir,
Okay.
from 5 we can again repeat, na, sir.
One
5
second.
S, 5, 5D,
5P,
5.
5S, 5P, 5D, 5F, 5G, it will come like this.
Okay, sir.
Okay. I will show you, see. Just I'm trying to show you. You're able to see screen, right?
Yes.
Yes, sir.
Okay. Now see, for example, if I'm taking, no, so these are the circles, right? See, 1S, how we can write, where we can see that. See, first cell only 1S. Okay. Second cell 2S, 2P. Likewise, we are there, no? Otherwise, we can see like this. See, getting how subcells are there, how it is there.
Sir, what is the difference between shells and, subshells and orbitals, sir? Is there any difference, sir?
Subcells and orbitals are both are same
Okay.
only. For example, let me see this. See this cell. This is nucleus, right? So in the first cell, how many are there? Thought 3 cells are there, no? 1, 3S, 3P, 3D. These are subcells like this. Okay, na? Have you understood how we can write subcells?
Yes.
Yes, sir. Sir, can you go to the previous slide?
Okay. This is the point of subcells. Okay. 1S, 2S, 2P, likewise we have done, right? Okay, na, Nana? Hello?
Sir, really diagrammatically like this only, sir, they will be.
Yes, in this one, I just now I have shown, no, in Google also. Okay.
Yes, sir.
This is about this. And one more point you need to write here only. I will write here. So generally, see here. Generally, what we can say, this is an orbital, right? In a orbital, we can place maximum 2 electrons only. For example, S orbital doesn't have any subcells, right? Okay, number of subcells of this that we can calculate by using magnetic quantum number. There I will write. So you will remember, no, L equal to 0 means S orbital. This part also you need to remember. Okay, na? This part you need to remember. Okay. And next part and coming into quantum numbers. And the L values also from where to where we are starting. Okay, this point you need to remember. Wherever I am giving some different signs, no, those points you need to remember. So there we are going to use in this one. And this part you need to remember. Okay. So if I'm going like this now, fifth cell will also 5 subcells are there. That is 5S,
Yes, sir.
5P, 5D,
4S,
5D,
5S, 5P, 5D, 5F,
5G it
F,
will be there.
and
But
6.
actually,
Six.
listen to me. But actually, what are the elements we are having right now? Okay, what are the elements we have right now? There are 118 elements are there, right? In periodic table, right? That elements while writing electronic configuration, no? So it doesn't need d orbital, g orbitals not required. Okay, so this is about the topic for today, and one more is there, that is magnetic and spin quantum number, that we will discuss. And before going to that, I will show you some shapes of orbitals also. Okay, see Nana. See, this is the shapes of d orbitals. Okay, shapes of orbitals, d orbitals. Okay, na? We have different d orbitals, like how it is looking, dumbbell shape it is looking, no? Okay, are you able to see my screen or not? Hello.
Yes, sir.
This is d orbital shape. Please try to remember this, huh? And see, this is how s orbital is there, no? See how it is looking like sphere, no?
Yes, sir.
Okay.
Yes, sir. Sir, at the beginning you named them, no, sir, S and the PX,
Yes, s orbital.
Yes, sir. S the orbital, no subshells.
S.
That's why only one is there, sir.
Yes. Okay, na? That subcells how we are defining, that we will see in magnetic quantum number. Okay, na?
Okay,
Right?
sir.
Okay, students. Next class we will continue remaining part. Okay. So good night, all
Okay,
of you.
sir.
Thank you,
Thank
sir.
you, sir.
Bye,
Bye,
sir. Good
sir.
night,
Good
sir.
night, sir. Bye, sir. Thank you, sir. Good night, sir.